Today's topic of discussion is Jorgensen's neoclassical approach for investment. Jorgensen's neoclassical approach for investment actually tries to determine the optimum capital stock. And what are the assumptions? The firms obviously try to maximize the present value and tries to derive the demand function. So what are the basic determination or what are the basic objective of the Jorgensen's neoclassical approach for investment? That is to determine the optimum capital stock, assuming that the firms are trying to maximize the present value and to derive a demand function for the firm. Now there are some assumptions regarding to the Jorgensen's neoclassical theory for investment, that there is a perfect competition in the economy and there is future certainty in the economy. Perfect competition and future certainty is very important assumption of the Jorgensen's neoclassical model, and expected price is equal to the actual price. That actually means that there is a future certainty in the macroeconomic variables. Next assumption tells us that the firm can borrow or lend any amount of money they want. So that is the availability, or that is the option that is available towards the firm, that they can borrow or lend any amount of money they want. Next assumption is that there is a perfect market for the second hand capital goods. Second hand capital goods are available in the market and you can sell or buy any kind of second hand capital goods. There is a perfect market for doing that. And obviously the firm would like to or would try to maximize the value. That means the objective of the firm is to maximize the value. That is the fourth assumption. Fifth assumption tries to tell us that the present value of the firm is to maximize Y. Y is basically a production function, and this production function is a function of capital and labor. So the firm would like to maximize the function or production function, and the production function is the function of capital and labor. Diminishing returns is there in the production. In the seventh assumption, it is assumed that labor and capital are homogeneous input. That means labor and capital are completely homogeneous and they are acting as input and they will produce homogeneous output. The inputs are kind of same type and the output that is being produced that are also of the same type. Same type of inputs, labor and capital are being used in the production process and they are producing output which are also of same type. Now production function Y is equal to function of capital and labor. If we do the first order derivative of the function with respect to capital, then it will be positive, and the second order and the first order derivative of the function with respect to the labor, that will be positive as well. So now flow of the net receipts at time t, that means net we may say that net profit of the firm at time period t. So what is the net profit of the firm at time period t? For going to that, we have to understand some terminologies. These are those terminologies. Now P into Q, as we know that P into Q are the total revenue. So here we are writing P of T into Q of T, T denoting the time period. So price of the time period T and quantity of the time period T, if we multiply that, we will get the total revenue. Similarly, W of T into L of T. W of T is basically wage of the labor and L of T is the amount of labor. So if we multiply the wage of labor into the amount of labor, then we will get the cost of the labor. Similarly, IT is basically the amount of investment and QT is basically the basically IT is not the amount of investment. I have tried to say IT is basically the capital used for investment, and QT is basically the rent for that capital. So QT into IT is basically the cost of the capital. T is just denoting the time period T. So if we want to derive the entire profit or entire net receipt for the firm, then it will be TR minus this portion minus this portion, total revenue minus the cost, that is equal to profit, right? So profit is equal to total revenue minus cost. So we are just writing here that RT which is basically denoted as the profit here. So profit, but we are writing it as net receipts. So net receipt at time period C. So that is basically total revenue, that is written as PT into QT minus WT into LT, that is the cost of labor, minus QT into IT, that is the cost of the capital. Now labor production function is basically a function of capital and labor. If we do the first order derivative of the function with respect to capital, then it will be positive. But if we do the second order derivative of the function with respect to capital, then it will be negative. Similarly, if we do the first order derivative of the function with respect to labor, it will be positive, and second order derivative of the function with respect to labor will be negative. We are going to do the, or we are going to set the subject, we are going to set the maximization form of the function. So this is basically the present value of the firm, which is written as in the form, we have to maximize this function, that is this function, we have to maximize this entire function, and that is the constant that is given to us is that kt is equal to it minus del into kt. Now kt or k dot t is basically the change in capital stock, which is denoted as it minus del into kt. Now we have obtained this function, or in this form. How have we obtained the function in this form? Well, this function was in this form. So now the value of rt is basically nothing but, this value of rt is basically nothing but, as we have written in the earlier forms, that rt is equal to pt into qt minus wt into lt minus qt into it. So we are just going to substitute this value of rt in this function, or in this value of function. So here we have just tried to substitute the value of the function here, and we have got obtained this function, and we have to maximize this capital stock subject to the constant that is given as k dot t is equal to it minus del into kt, that is basically the capital stock remaining. Here we are going to obtain the dynamic optimization of this function. We are denoting the function as ht, and we have written the entire function. Now here, as we are doing the dynamic optimization, so we are taking lambda t into the constant function. This is basically the lambda t, and into the constant function is written as it minus del into kt. So this constant function is written, and lambda t is also written with the constant function. So we are going to do the derivative of, or the partial derivative of this ht with respect to kt, with respect to it, and with respect to lt. So we are going to do the partial derivative of this function with respect to kt as first, then we are going to do the partial derivative of the function with respect to it, and we are going to do the partial derivative of the function with respect to lt as well. We have to remember that all of these partial derivatives with respect to kt, it, and lt are equal to 0, but in the case where we are doing the partial derivative of the ht with respect to kt, then we have to write it as equals to minus lambda t. For understanding that, we have to understand that what is basically lambda t into kt. What is basically del ht by del kt. Del ht by del kt is basically the marginal value of an additional unit of capital. If you increase an additional, or if you give or increase an additional, or if you increase the value of capital by 1 unit, how many unit, or by how many unit the value will change? The value of ht will change. That means if you increase the value of the capital by 1 unit, by how many unit the value of ht will change? So this is basically giving us del ht by del kt. So del ht by del kt is basically marginal value of an additional unit of capital. So marginal value of an additional unit of capital is basically del ht by del kt. but this lambda t is also giving us the marginal value of an additional unit of capital. So we can write this entire form as equal to minus lambda t. From the equation 2 that is obtained here, we can easily simplify it a bit, and we can find out that lambda t is equal to e to the power minus rt into qt. If you write the equation on your notebook and try to calculate or simplify it a bit, then you can easily find out the value of lambda t, that will be equal to e to the power minus rt into qt. So it is also written here that the value of lambda t is nothing but e to the power minus rt into qt. Now lambda t is basically e to the power minus rt into qt, from where we have actually obtained this lambda t value. Now for getting to the value of this lambda t, we have to take the help of the equation that we have derived in the earlier page. So that what is actually this actually trying to denote, or what is the representation of this equation? That is, the marginal cost of investment is equal to the shadow price. What is, we obviously know the marginal cost of investment, right? So what is basically the marginal cost of investment? Basically marginal cost of investment is that if you increase the cost by 1 unit, by how many unit the investment will change. So that is basically the marginal cost of investment, and that is equal to the shadow price. That means shadow price is basically, suppose there is a product and the price of that product is not assigned yet, but we are assuming or expecting a price. Suppose there is a laptop brand called Asus VivoBook 17 that is not still, it is launched, but the price is not assigned yet. So suppose we are assuming a price value for that particular product. Suppose we are assuming 1,05,000 rupees as the value of the laptop. So this 1,05,000 is not being assigned by the company, but we are assuming or expecting this value. So this is basically the shadow price. Now this equation is telling us that the marginal cost of investment is equal to the shadow price. From 3 we can easily derive this, and you can easily find out this from 3. So that basically means that the marginal productivity of labor is equal to W. That means wage for the labor is basically equal to the marginal productivity of the labor. Now lambda t is basically denoting here marginal value of additional unit of capital. What an additional unit of capital is giving, what value is giving or is being given by the additional unit of capital. So basically here lambda t is trying to denote the additional value or marginal value of an additional unit of capital. What value is being given by 1 unit additional capital, that is basically denoted by lambda t. Now putting the values in the lambda t of lambda t in del ht by del kt, we are getting this form. So this is basically very easy derivation. You can easily note down and understand this derivation, and at the end we are obtaining this fkt. This is basically the this fkt into lt. We can find out the value of this fkt into lt, and that will be equal to qt into r plus del minus q dot t is equal to C. We have assigned C here because this is basically the user cost of capital. You cannot, if you don't want to assign C, there is no requirement to assign C. This is basically, this part is basically the user cost of the capital.